Hi, my name is Medhat Elmasry. Today I'm going to talk about machine learning.net. This is a new library that was released by Microsoft about 6 months ago, and it's still in preview. The version number is 0.5. It hasn't even reached 1.0. So let's get started. Now, this is the latest addition to the family of .NET, and it works with Dotnet Core. So among the things that you can do with Dotnet Core, you can build desktop applications, web applications, cloud applications, mobile applications, gaming, and IoT applications, and this is the latest in that family. So what is machine learning? An example of that is if you send an image to a machine learning engine, it can detect for you whether this is a face or not a face. So there is something like a function out there that can analyze the image that you're giving it and decide whether or not this is a face. As an example, that function, you can give it a face and it will tell you, no, that's not a face, or give it a face and it says, yes, that's a face, and so on and so forth. The types of machine language algorithms that are available today, generally, they belong to one of these categories. The first one is classification, where the engine can tell you whether something is A or B or C. Is it a face or is it not a face? Is it an animal or is it a human? The other type of category is regression, where you give it a lot of data and it sort of trains itself on the data that you're giving it, and you can make future predictions about something. The third one is clustering, where it takes your data and it categorizes it based on some sort of logical grouping. What is ML.NET? Well, a lot of the services that you have on Amazon, on Google, on Microsoft Azure, they have already services that are speech recognition, image recognition, and these are already built models that they provide you with, and you don't really need to understand how that model was made, what algorithm it's following. All you do is send it an image and it will give you back some sort of result. Or send it a text and it will tell you whether the sentiment is positive or negative. What this talk is all about today is building your own machine language model based on something that you want. It may not be available in the services that are on these cloud platforms, or it could be a service that's available on one of the cloud platforms, but you think that you can do it a little bit differently. Here's an example of what they call cognitive services on Azure. You can send it a sentence and it will tell you whether it's got a positive sentiment or not. If you send it a message like, this is a great vacuum cleaner, it will come back with a positive sentiment. In this example, it's going to tell you that 96% this is a positive sentiment. But suppose you send it another message along the lines of, this vacuum cleaner sucks much dirt. What do you think it's going to come back with? The word sucks, it associates it with something that is negative. So it's going to come back with a thumbs down and say, this is like 9% positive. But the sentence actually says that this vacuum cleaner knows how to suck dirt, and this is supposed to be positive. So in a case like that, you might say, oh, I'm going to create my own model. So to build your own model, you need to get a good source of data. You have to prepare your data in a manner that is conducive for your algorithm to sort of digest that data and process it. Once you have a good data source, you can build and train that data source. You can even test the data source by evaluating it. After you've done your model, you can evaluate your model against another data source and get a sense of how good your prediction or your model works. Finally, when you're happy with it, you can start using it. C# and .NET is actually a new entry into the world of machine learning because the most popular languages for machine learning are, without any doubt, at this moment in time, Python and R. So with the new introduction of ML.NET, even though it is not rich yet, it's hoped by Microsoft that it will be important as they evolve the framework. Internally at Microsoft, they have been using this library already. Internally, their ML.NET framework has been used for the last 10 years in their tooling and their applications. Like in this particular slide, you can see that it's being used in Bing, Excel, PowerPoint, and Windows 10. ML.NET is an open source platform. If you want to check it out, you can go to this GitHub site and you can follow the open source project. If you want resources and tutorials and documentation, you can go to the link at the bottom here, which is essentially .NET, and you can click on machine learning and AI, and there are quite a few tutorials there. Now, ML.NET is all about what we call pipelines. I'm going to give you an example on this. We're going to build a taxi fare prediction model. And the source of data that we're going to be using originates from New York. I have over 1 million records of taxi trips that happened during a period of time in the city of New York. And my data set has the following columns. The first column is a vendor ID. And this is just the ID of the company that runs the taxi. The second one is a rate code. This is a rate type for the taxi. The third one is a passenger count. How many passengers were there during a particular ride or a particular trip? The third one is the trip time in seconds. How long did that trip take? The fourth is a trip distance. From A to B, what was the distance for that particular trip? The payment type represents how the payment was made. Was it made by credit card? Was it made by cash or any other means? Finally, the last column in my data set is the fare amount. Now, if you look at this data, the one thing that you can try to predict is really the fare amount, which is the last column. Now, the data that you want to predict is called a label in the language of machine learning. Looking at these columns, it's also worth identifying the columns that are more like lookup tables. And they are: vendor ID is like a lookup item. Rate code is also a lookup item. And payment type is somewhat of a lookup item. The one column or item of data that we will disregard in our model is the trip time in seconds. Because when you're trying to make a prediction of fare amount, the time in seconds is really irrelevant. Because you will come across 1 traffic light, 10 traffic lights. There could be congestion, there could not be congestion. It could take longer, it could take less longer. So we're not gonna put that into our model. So let's get started with some code. I've opened up Visual Studio here, And at the moment, I'm using Visual Studio 2017. And the actual version of that Visual Studio is this version here, 15.9.0. And I'm using the preview version. If you're not using the preview version, as long as you're using the latest update for your Visual Studio, you should be okay. I'm going to start a new project. And to make it very easy, the type of project is going to be a simple .NET Core console application. I shall save it in a place where I can find it. So I'll put it here. And I'll call this taxi fare prediction. Now, the first thing you should do after you create your project is to come into the properties of this application. Click on the Build tab and change the target platform to x64, which is this. And another thing you need to do is make sure that the version of C# that is being used here is later than 7.0. So 7.1, 7.2, 7.3 is fine. And the way to do that is to click on this advanced button down here and change the language version to 7.3. I could also use 7.1, 7.2, but I have chosen to use the latest version. So I'm going to use 7.3 at the time of recording. The next thing we want to do is get some data. So I'm going to add a folder called data. And I'm going to put into that folder data that I obtained from the taxi service in New York. And I have the data with me right here. So I'm going to drag and drop this into this data folder. That's one data file, and this is the other data file. Because we want these data files to be copied to the target binary folder, I need to come to these files, go to their properties, and change this setting, copy to output directory. I need to change that to copy if newer. I need to do that for both files. So I've done it for the first, and let me do it for the second one. Now let's have a peek at the data here. The data is in comma separated value format. Going back at looking at this data, one is the data that we're going to use for training our model, and the other one, its name is taxi fare test, and this one we're going to be using for evaluating whether our model is good enough or not. If you look at the contents of this second file, which is the file we're going to be training with, let's open it up. And I must warn you, it's a very big file because it's got over 1 million records. The richer your data set, the better your model is going to be. So if you look at the columns we have here, here they are. These are the columns I mentioned in my slides. And let's go to the bottom and see how many records I have. I have 1,048,000 plus records, so it's pretty rich. Let me close this and have a look at my test data. How many do I have for my test data? I have about 1 million records for my test data too. There is a rule of thumb that says if you're testing a model, your test data should be at least 30% in terms of size of your original data. So we have more than 30%. We have a lot of data here. We have to create two classes. The first class is our input, and it is pretty much a mapping of the columns in our data source. So the first class will basically map these column names in my data. And the second class is the output. So the first class that we're going to create is an input, and it represents the columns in my data source, and the output is basically what do I want to predict. And we said what we want to predict is the fair amount. So let me create these two classes. Add class, and the first one I shall name taxi trip. So this is the name I'm giving my first class. And my second class, I shall call it taxi trip fare prediction. So this is the name of my second class. I've got the code for these two classes. So my taxi trip will look like this. It will require a column attribute which really belongs to the Microsoft.ML package. Now I haven't installed that package. So let me go to the NuGet package manager. I'm going to choose manage NuGet packages here, and let me install this package that I need to build these ML.NET machine learning models. I'm gonna click on browse here, then I'll enter Microsoft.ML, and sure enough, having entered this, it did find for me a package called Microsoft.ML. Let me install this. Having installed that, let me close this, go back to this class that I just created, taxi trip. We need to resolve this column attribute. So we will use this option. There are two places where this column attribute can come from, but we want it to come from the Microsoft.ML package. So let me resolve that. I don't have any errors now in my class. Let's look at what we've got in this class. This class is essentially a mapping of the data source. Each property here represents a column in my data source. So I have a vendor ID, rate code, passenger count, trip time, trip distance, payment type, and fare amount. And just a reminder, this trip time, I'm going to import it, but I'm not going to use it. And the other thing that's important is what I'm trying to predict is the fare amount. So that takes care of this class. The second class, so here's the code for the second class. Let me resolve this. Now this second class represents the output or my prediction. This is what I'm trying to predict. And I'm giving this column a name score. So we have two classes here. We're done creating these two. The next thing we need to do is put some instance variables into our program.cs file that point to the data sources. And I've got some code for that. So I'm going to add these variables here, and all that these variables do is they point to the various files that I want to use as my data source, plus the file that I will be using to save my model. This here is my data source, and this is going to be my test data, and this is the name that I'll be giving to my model, my machine learning model. Let me resolve this path class. I'm going to replace this console.writeLine statement with my command that will be training my model. So I need to resolve this prediction model class. This is basically saying that the first step is to train a model. When you train a model, it's going to return a model object, which is a prediction model object based on this input and that output. So I do not have a train method, so let's create a train method here. So I'm going to add an empty train method. Now this train method has to return a model. The first thing you do when you're training is to create a pipeline, and it's all about the pipeline. So I need to instantiate a pipeline. Once you create a pipeline, you need to load the data that you have into that pipeline. That's step number one. This code will load the data identified by this variable into the pipeline. Make sure that when you're resolving this class, you use this package, Microsoft.ML.legacy.data, this particular assembly. The next step in building your pipeline is to identify what is your output. And the output is what we said is the fair amount, and we're going to call it the label. So this is the next thing we do in our pipeline. We're going to say what we are going to use for prediction is the fair amount, and it is identified, or it is referred to as a label. The third thing we want to do is to identify the columns that are really category columns, and I mentioned before they're like lookup type data columns. And this says that vendor ID, rate code, and payment type, these are lookup type, category type columns. That's why to the pipeline you add this categorical one hot vectorizer. The next step is, what are our data items that also in the lingo of machine learning is called the feature items. The feature items are the data items that collectively constitute data that can help us in predicting something. And I mentioned to you in the slides that all the columns are important in making predictions except the column that pertained to the time in seconds of the trip. So we need to add the columns that make up our feature. And the columns that make up our feature are all the columns except the column that had to do with time and the column that has to do with our data we are going to predict on. So these are the columns: vector, ID, rate, passenger count, trip distance, and payment type. These are pretty much the columns in our input that we're going to use for making a prediction. The next thing we want to add in our pipeline is the algorithm that we're going to use to process this information. I did mention before that generally there are three types of algorithms. There is the classification, there is the regression, and then there is the clustering. This is an example of regression, and there are built-in algorithms that help you to choose different ways of doing regression. I shall be using this library called the Fast Tree Regressor. There could be others. If you find that this particular algorithm is not helping you, you can go and try with a different algorithm. So let's resolve this. The next step is to actually train our model. We have set up all the plumbing. We should tell this class here, the regressor, to go off and train. Look at the data, see some sort of similarities, consistencies, some order in the data, and try to build a model based on that data. So this is where you tell the model to go off and get trained. So we know here the algorithm we're using, so we say to the pipeline, go and train yourself based on this input and this output, and return a model object. Once we have the model, we probably want to save it somewhere. So we're going to come here and add these lines of code. The first line of code says, go off and write the model. And write it where? Write it in this model path, which is the zip file. It's going to write the model in a zip file. And then return the model, because this particular method, it's got a return type of model. Now, because this is using async, our method signature has to reflect the fact that this is an async method. So we have to change it so that we say async task of that. We need to resolve the task class here. And this belongs to the system.trading.tasks assembly. So now this method seems to be good. We have another problem here. When this train method is being called, this train method is an asynchronous method. We need to put the keyword await before train, and we have to change the method signature to be async. So we're going to change this to async task, and that should be fine. At this point, we can run this application, and the end result will be that we will get a model saved in the file system. So let's run it. If you look at the verbose output, it does say starting to train. So it is the regression algorithm and the pipeline that is training the model. And if we go back to the file system here, we should see that a model has been created. Let's go. Open folder, and if you go to the bin debug directory, you will notice that because we said that the data needs to be copied, the data has been copied here. And in addition, this file called Model.zip, it has been created. Now this Model.zip is interesting because if you created a model and you want to give this model to a friend who wants to consume it without having to do any training, you just give them the zip file and they can use that model to predict using your machine learning model. So let's close this and continue. So we said the first step is you want to train, and then the second step is you want to evaluate whether your model is good enough or not. So we now have a model at this stage, and we have some test data. We're going to use that model against the test data to see how well we're doing. So I want to add to this main method a call to a method that I'm going to create in a minute, and it's called evaluate. And I want to pass it my model so that I can determine how well it is doing. So again, I don't have a method called evaluate. I shall start building it. I'm going to add a blank evaluate method. And this evaluate method, it's just going to take the model that we created, and it's going to give me some metrics on how well that model is capable of doing its predictions based on test data. Again, when we're doing an evaluation, we need to load our test data. So this line of code simply loads our test data into the application using the format that's described by this class. And you can see here that you've got a property that says what is the separator, and because this is a comma separated file, the delimiter here is really a comma. The next thing we want to do is use an evaluator that knows about regression. So we're going to instantiate a regression evaluator. And with this evaluator, we're going to evaluate the model using test data. So this line of code says, okay, you know what evaluator you've got? Take the model and the test data and do some evaluation on it. This returns some metrics, and the metrics will give us a sense of how well we are doing. So there are two items of metrics that we're going to look at. Let's add them here. The first one is an RMS metric, and the RMS metric, the smaller it is, the better your model is doing. And then there's another metric called R squared, and this gives you a number between 0 and 100%. The closer you are to 100%, the better your model is doing. So at this stage, let us run again and see how well is our model doing based on the test data. So let's run. Here are the metrics. The RMS value is 3, which is low and it's okay. And our R squared value is 88.6%, almost. And this indicates that our model is somewhat reliable. But we haven't made a prediction yet. The next step is, let us give our app some data regarding a trip that we want to make, and let it predict for us what the cost might be. I have here a method that I'm gonna add to my program.cs, and basically this returns a trip that I want my model to predict. And the trip looks like this. I'm saying, okay, if the vendor is VTS, this is a taxi company in New York, and the rate code is 1, the passenger count is just 1 passenger, and the distance is 10 miles, 0.33, and the payment is going to be done in cash, what is the fair amount? And here I set the fair amount to 0 because this is what is going to be predicted. But I know that this particular trip costed $29.5 US. So I want to give this to my model and tell it, hey model, with these parameters, what do you think is a good prediction for this trip? How much will it cost? So simply at this stage, if you go back to the main method, I trained, I evaluated, and now I'm happy with the model. The next thing is I'll use the model to do a prediction. So here is the code. Using the model, predict based on this data, and from the prediction, give me the fair amount. So now we are ready to run the app again and see what the prediction of our model is. So let me run this. Here is our prediction. The prediction is $31.14. How does it compare with the actual amount? 29.5. It's not very far actually. It's almost $1.64 away. So that's a reasonable prediction. Now I told you that the Model.zip file, you can literally give it to somebody and say, hey, I have this model, use it. You can even sell it. So let us see how we can use the Model.zip file to make a prediction without having to go through all the stuff that we did here. To prove to you this point, I'm going to comment all the logic in the main method. I'm going to comment it out. And I'm going to use the code in here simply to read my model and make a prediction. And I don't need to do any training. I don't need to do any evaluation. This could have been a web app. It could have been an Android app. It could be any app where you give them the model and they can make predictions based on that model. So I'm going to add a method here that I call predict. And what this method does is, the first thing is go and read this model from the zip file and put it into a model object. And then using this model object, predict the cost of a trip. Now this object trip is an argument to the method, and then return the prediction. So as simple as that. These are literally the 2 lines of code you need in order to use a model to make a prediction. As simple as that. So let me use this. So after I commented out all the code in the main method, all I want to do is call my predict method, give it the data, it returns a prediction, and I want to display the prediction. And again, a reminder here is that I'm simply using my Model.zip file that I got from a friend, for example. So let's run this and see what it gives you. And here it is. My model, which is nothing but a zip file, it has returned the same prediction as we had before. Let's have a look at the size of this Model.zip file. This is a very small file. It's only 77 kilobytes. So the whole model that you created based on over 1 million records is nothing but 77 kilobytes. Thank you for coming this far in my video, and I hope to see you in other videos. Goodbye.